Today we're going to be working with the Pythagorean Theorem. We're going to use models and diagrams to explain it. We're also going to use the Pythagorean Theorem to solve problems. The Pythagorean Theorem is a mathematical equation that states a squared plus b squared is equal to c squared. I will explain each one of those letters in just a moment. The Pythagorean theorem only applies to right triangles, so let's begin by discussing what those variables means as it relates to a right triangle. In a right triangle, we have two legs. This line is considered to be a leg, and this line is considered to be a leg. And the way you will know your legs is because it will be the two lines that are perpendicular and they form the 90-degree angle in your right triangle. Again, those two sides are called legs and they form the right angle in your right triangle. So your legs A and your legs B are the first two pieces of your formula. Now let's talk about the other piece. The hypotenuse is the longest side of the triangle. It is opposite the right angle. What that means, this line is the longest line of your right triangle. It is the line directly across from your 90-degree angle. So if at any point you get confused about what is the hypotenuse, just know that it's across from your 90-degree angle. And it is C in your formula. In real world problems, the hypotenuse is often called a diagonal. And that's because, again, it's a diagonal line. And it's right across from the 90-degree angle. Okay, let's move on to part B. In a right triangle, we can prove the Pythagorean theorem by using a model. Remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. So basically with the model, it's saying that if you take three squares, the sum of the areas of the squares of the legs. So remember that when we have a right triangle, the two lines that are perpendicular that make the 90-degree angle are your legs. So I have leg A and I have leg B. And it says the sum of the area of the squares on those legs. So if I look at leg A, I have side length 3, side length 3. Multiply those together, I have 9. Leg B, I have 4 and 4. Multiply them together, I have 16. When I add them, I get 25. And that sum is equal to the area of the square on the hypotenuse. Remember, the hypotenuse is a line directly across from the 90-degree angle. It's also your C. If I look at my side lengths, I have 5 and 5. When I multiply those together, I get 25. So that is how we can model and prove the Pythagorean theorem. Let's move on to part C. In part C, just going to use the Pythagorean theorem to find missing side lengths of a right triangle. Whenever you have a right triangle and you're using the Pythagorean theorem, you would have been given two pieces and you're looking for like that third length or that third side. The first thing we always want to do is write the formula. So I have a squared plus b squared equals c squared. One thing I like to do is just go ahead and identify what's going to be A. So my 3 side will be A. My B side is going to be 4. And C is what I'm looking for. Then you want to plug in known values. So I know A is 3. So I'm going to replace it with 3. B is 4. And C, I don't know. That's what I'm looking for. Simplify just means to work any math that you can do. 3 times 3 is 9. 4 times 4 is 16. And I have c squared. On the left, I still have some math I can do. I can add 9 and 16, which is 25. And on the right, I still just have c squared. But because I have that square, that number 2 as an exponent, that lets me know that I don't know That's not just one c. That is c being multiplied times itself. And the only thing that can undo or reverse a square would be finding the square root. So that's why in this box I have take the square root of each side. So I have to take the square root of the 25 and take the square root of c squared, and I will have my answer. So the square root of 25 is 5, and the square root of c squared is c. So for c, my answer is 5. If I want to check it, remember at the very beginning we said that the hypotenuse is the longest side. That means it's the largest number of the three. And when I look at it, my hypotenuse is bigger than my legs. So I know I'm in the right direction, plus we can always just check it. Let's go to the second one. On the second one, we're actually looking for a leg. So I'm looking for a leg, but I can use the same formula. So I'm going to write a squared plus b squared equals c squared. A, I don't know what it is. I'm going to write a squared. B, I know it's 12. And C, I know it's 15. And let me just identify again for you. So I know this is A, this is B, and this is C. I'm just going to simplify. So A squared plus 144 equals 225. Going to subtract 144 from both sides because the goal is to solve for the variable. So I have a squared is equal to 81. I'm going to take the square root of both sides. And I know just 1a will be equal to 9. So that means a is 9. I'm just going to do a quick view, and I can see that I have 6, 9, and 15. My hypotenuse side is larger than my A and my B, which are my legs. And we can always just input 9 in our original formula in order for us to check it. Let's move to the last piece of our video. For the last part, we have a real world situation. We have Jane and McGill, who are siblings. They go to different schools. Jane walks 6 blocks east from home. McGill walks 8 blocks north. How many blocks apart would the two schools be if you could walk straight from one school to the other? I'm going to quickly make me a compass. I have north, east, south, west. I know that they go to different schools and they're going to start from home. So I'm just going to write an H for home, and I'm going to put a dot to represent home. Then the first thing I'm being told is that Jane walks 6 blocks east. So I'm going to draw a line to represent Jane's walk. And then I'm going to write that it is 6 blocks. And I know this is Jane. So I'm going to put a J. Then I have McGill, who from home walks 8 blocks north. So I'm going to start from home and draw a line going up to represent north. And this is McGill, and it's 8 blocks. And my question is asked me, how many blocks apart would the two schools be if I could walk straight from one school to the other? So remember here, I'm not thinking about home, I'm thinking about school. So I'm going to draw a line from McGill's school to Jane's school. I could have drawn the line from Jane's school to McGill's school. It doesn't matter. I will still have that line drawn. When you draw that line, you should notice, or you should see, a triangle. We know that it is a right triangle because when we drew the blocks, we formed a 90-degree angle because they are perpendicular to each other. So that means if I'm looking for this information here, I can use the Pythagorean Theorem. The Pythagorean Theorem is a squared plus b squared equals c squared. A, I'm going to use as 8 blocks plus b, and b, I'm going to use as 6. 8 squared is 64, b squared is 36, equals c squared. When I add 64 and 36, I have 100. which is equal to c squared. I need to get that square off of the c because I need c by itself. The way I do that is to find the square root. That undoes a square. So 10 is equal to c. That means that this x, this is 10. So the answer to my question is 10 blocks apart. That will conclude this video. You guys have a great day.